Moving on to question 3 here, we have a question on polar coordinates. So we've been given this polar equation here, r is equal to 0.4 plus a cos 2 theta, and the range is between 0 to 2 pi. So what we've got going on here in this question is we've got this top of the table here. The shaded parts are in wood, and then this curve here is the glass part of the table. And for part A, we're asked to show that A is equal to 0.2, so a nice easy 2 marks. And then for part B, this is a very standard kind of question for polar coordinates. You've got to find the area of the shaded parts here. So this is the wooden part. So let's just jump into part A straight away. So we've got to show that A is equal to 0.2. Well, we've got this length here, AB, is 1.2 meters, and we don't really have anything else. We've just got the polar equation. Well, let's consider some values for theta, right? So if I say straight away, what about when theta is equal to 0? Okay, so if theta is equal to 0, then we're going to be at the origin, the pole of this equation, right? And this curve. So we're going to say theta is equal to 0, and if we're at the origin here, the pole, well, this length here, this 1.2, will clearly be half. That would be 0.6, right? So what we can say is that 0.4 plus a cos 2 theta, so plus a cos 2 theta, a cos 2 theta, this is clearly equal to 0.6, right? 0.6. Well, solving this now, I can take 0.4 off both sides, so it's going to be a cos 2 theta, and this will clearly be equal to 0.2. 0.2. So we said that theta is equal to 0, so cos of 2 times 0, so that the cos of 0, well, cos of 0 is just 1. I've got a times 1 is equal to 0.2, so therefore a must be 0.2. And there we have it, that's a nice easy 2 marks to start this question off, so 0.2. Okay, so that's part A done. Let's jump into part B now. So there's a bit more going on with part B here. So we're given that the length AD is equal to 60 centimetres. So this length here is 60 centimetres. Now, for this question here, we've got to work out this area for the shaded parts. Well, how would we do that? Well, if I can work out the area of the rectangle and then minus the area enclosed by this curve here, then we can work out the shaded parts, because that's all we get left with. So let's work out the area of the rectangle first, then we can work out the area of this curve here, and then we can subtract them to get the shaded parts. So the rectangle is nice and easy. We'll call it RECT, rectangle. This will just be 1.2, because that's my length here, times by 0.6, because it's in centimetres here. So 1.2 times 0.6. That's going to be 60% of 1.2, so that's going to be 0.72 there. Okay, so we've got the area of the rectangle. So I'm not going to put any units or anything just yet. We just need the value. So we've got the area of the rectangle. Now let's have a go at working out this area here underneath this curve, enclosed by the curve. So if I call this C now for the curve, well, the area, so if I call this the formula A, so curve, well, the formula would be A. So this is given in the formula, but you don't have to worry about memorising this. This is going to be A is equal to a half times the integral now. So I'm not going to put my limits on just yet. We'll come to that before we perform the integration. So it's going to be r squared d theta, r squared d theta. Okay. Well, we know r is 0.4 plus 0.2 cos 2 theta. So all we've got to do now is sub in our r, square it, and then start performing the integration. So this will be now equal to a half times the integral of r squared. So I'm going to put 0.4 plus 0.2 plus 0.2 cos 2 theta all squared. Cos 2 theta all squared. Okay, so now we just need to expand this as a double bracket. So I'm going to do this down here. Well, this is going to give me a half times the integral of, so this will be 0.16 plus plus 0.16 cos 2 theta. So I'm kind of just skipping. I'm not going to actually show me expanding this, but 0.16 cos 2 theta. 0.16 cos 2 theta. I'm going to get 0, and then I'm going to get finally 0.04 cos squared 2 theta plus 0.04 cos squared 2 theta. And this is with respect to theta. Okay, so in this bracket now that we're going to be integrating, everything's fine minus this cos squared 2 theta. This is a bit of a problem, right? This isn't straightforward to integrate. So how can I deal with this cos squared 2 theta? Well, I've got to go back using my identities from A-level maths to get this into a form that we can integrate and, you know, it being a lot nicer to work with. So I'm going to kind of work backwards to get to that. So if I do it over here, so if I've got, say, cos 4 theta, okay? So you kind of got to know the identity for cos 4 theta. Well, cos 4 theta, well, that's going to be equal to cos squared 2 theta minus sine squared 2 theta. So cos squared 2 theta, cos squared 2 theta minus sine squared 2 theta. Okay. Well, cos squared 2 theta minus sine squared 2 theta. Again, we can use our formulas and our identities. Well, this will be equal to cos squared 2 theta minus, so it's going to be cos squared 2 theta minus 1 minus cos squared 2 theta. So minus 1 minus cos squared 2 theta. So just be very careful with your signs here and what you're actually subbing in. It can be very easy to make a mistake. Okay, and now I'm just going to keep simplifying here. So this is still cos 4 theta. So this is going to be equal to 2 cos squared 2 theta minus 1. So don't forget this is cos 4 theta. So cos 4 theta. So therefore, we can get this into a form now that we can work with. This is going to be, so this is 0.04. Well, cos squared 2 theta will be cos 4 theta plus 1, so I'd add 1 to both sides, and then divide by 2. So, therefore, this will be 0.04 lots of cos 4 theta plus 1 divided by 2. Okay, so we've got that now. Now we can start doing the integration. So I might just run out of room here. I'm going to pray that I don't. Let's see if we can do it. So a half times this integral, and now where I've got this 0.04 cos squared 2 theta, this is what I'm going to replace it with. So I'm not actually going to show me, expanding this, but that's what we've got. And don't forget, I've got 1 over 2 here, so that would be a half, times it by 0.4, so I'm going to get an extra 0.02. So when we start integrating this now, what I'm going to get is a half times, so in my bracket, this is what I've got integrated, 0.18 theta, because this was 0.16 plus 0.02, and then we can integrate, so we get 0.18 theta plus 0.04 sine 2 theta. 0.04 sine 2 theta plus 0.0025 sine 4 theta. Okay, so 0.0025 sine 4 theta. Okay, now we haven't discussed the limits just yet, but let's have a think about what we've got going on here. We know theta ranges between 0 to 2 pi, so, and we want the full length of this rectangle, right, of this curve. So, my limits are going to be 0 to 2 pi. So, 0 to 2 pi. Now, you don't have to pick these limits. You could have done, for example, 0 to pi, but you then have to times this your answer by 2, for example, to make up for the other half of the curve. So you can pick, you can even pick 0 and pi over 2, but again, you then have to times that by 4. So It's completely up to you guys, but I think 0 to 2 pi is just the easiest to work with. We don't have to times it by anything else. So, if you put this on your calculator, what you're going to get here is 9 over 50 pi. So 9 over 50 pi. So 9 over 50 pi. So therefore, we can now work out the area of the shaded part. So, if I call it S for the shaded part, this is going to be equal to 0.72, so the rectangle, minus the curve. So that's going to be minus 9 over 50 pi. 9 over 50 pi. So this will be equal, so it wants it to 3 significant figures, so make sure you don't trip up just with that last easy part. That'll be 0.155, and then don't forget your units. We're working in meters, so meters squared. And there we have it. It's question 3, fully complete.